Hi everyone, Daniel Bryant here. Just debugging some AWS Lambda code with Java this afternoon, and I wanted to look around for some best practices online, and I actually couldn't find that many. So I thought it might be useful to create a very short video just to demo how I'm using IntelliJ to debug a ridiculously simple Lambda function that I'm running locally via the AWS SAM local kit. Real nice bit of kit this is. It's created by the AWS folks. Basically it allows you to spin up a AWS Lambda function locally, and you can also hook in a bunch of sort of fake event data. You can create fake event data from various event sources in Amazon, pipe them through to your Lambda, see what happens, and you can also run a local API gateway or simulate a local API gateway to allow you to do some browser-based testing. It's a nice bit of kit. Find their stuff on GitHub. It's quite a simple install and so forth. It does require Docker. It actually uses Docker under the hood to spin up a container with Java in my case, but whatever language you're using, spins up the runtime, deploys your function, and pipes the data through to it. But on to the main thrust of the actual video. You can see in my right hand window here I've got a ridiculously simple product catalog function. The product catalog function, all it does is return a series of products. It actually comes from my Docker Java shopping example that I've previously sort of shared via O'Reilly. So there's a mini book. You can Google around and find my mini book that explains more about the actual very simple application. But for the moment, all you really need to know is that this function will be called via an API gateway. So a user or a service makes a call against the API gateway, and it simply returns a list of products. You can see down here actually it's calling out to product service, which I've created. It's all hard coded, trying to keep things as simple as possible just to talk about the machinery in my other book coming up, which is CD with Java with Abraham Marin Perez. So the two of us are working on this. So trying to focus on the CD mechanics, on the debugging mechanics and so forth, and keeping the actual function itself super simple. So this is the function we want to debug. Now I've used SAM init. So SAM init is the SAM local toolkit. Provides a sort of framework generation. Do SAM init, name your project, and it spits out a very basic Maven structured project, Java project, and it also spits out the POM, which contains all your information that you need. We can have a quick look now. I've just added JSON, Google's JSON for parsing some JSON data, but fundamentally it comes with AWS Lambda Java Core, JUnit, and we're using Shade to actually build the Java jar that's going to be run as part of the AWS Lambda. Now, the part of the SAM init also generates what's called a template YAML file. And template YAML file, it's basically the infrastructure as code. It's all the mechanics we need around deploying our Java jar into ultimately Lambda, AWS Lambda remotely, but also when we're running it locally as well. So I've tweaked the actual default config a little bit. I've changed the name from hello world to product catalog function, but other than that it's pretty straightforward. I'm specifying that when I've done a Maven clean install, I build my jar and I'm running it. This is the main function, the handler that actually is called by the gateway will be product catalog function, which we looked at just a second ago, and we have the handle request method. Now the rest of the config here is not so important. When you deploy remotely it becomes more important, but the actual local demo is not so important. But you will need not only your Java code, your Java jar generated as well through something like Maven and Shade, but you'll need your template YAML to tell SAM local how to package up, how to spin up your Lambda locally. Now once you've got that one up and running, of course you can do all your standard unit tests and your integration tests in the Java world just as you're used to, but you can invoke it locally. Two methods: you can do a SAM invoke local, or you can run a sort of fake gateway locally. Now you can generate data. I've done a couple of pre-canned ones here already. We can use SAM local on the left window here to generate an event, and I'm choosing API because I want to debug against an API event coming into my function. I'm specifying -m, the method is get, the HTTP method, and I want an empty body in this case. I'm simply making a very basic get request against my handle request here, with the gateway, the Amazon API gateway, sitting in the middle. So if I do a generate event here, hit return, you can actually see SAM local will spit out some JSON that would the gateway, when it's in production, the gateway would generate this JSON here and send through to my Lambda running in a container. Now obviously the SAM local generate event, we can mess around with this this data here. We can say pipe this data to a file, add our own kind of config. Obviously we need to keep the structure the same because that's what the Lambda is expecting and what obviously the gateway generates in production. But you can alter things like the query string params, you can alter the method if you want. I often find myself just playing around to get the exact data I want to say run this JSON file in a integration test that I spin up with JUnit and so forth. When I'm just playing around up front, I often use this actual I often used a SAM local generate event API, but I pipe it through to a SAM local invocation of, in this case, the product catalog function. Now when I'm testing, I often use the SAM local generate event API, but I pipe that data, that JSON we saw just a moment ago, I pipe it through a local invocation of the product catalog function. Now the SAM local invoke product catalog function you see here, it uses, I'm in the actual directory with this config, and it uses the template YAML to spin everything up. You'll notice the SAM local invoke, the function name is specified in the resources within the template YAML, and I can simply hit return now. Under the hood, SAM local will spin up a Docker container with Java 8. It will deploy my function into that container, and you can see here the results of the test. I've got like a JSON body. Obviously, I could use JQ to make the data look a bit nicer, but at the moment, I've just got a JSON body coming back with the data I wanted. So really simple. I'm using the generated event from an API gateway, piping that output, the JSON you saw just a moment ago, into a local invocation of my function on the right here, running in Docker. Now I do need to do a Maven clean package or Maven clean install in order to get the latest version of that function, because the template YAML uses the target/product catalog jar. So if I wanted to update my Java code, I'd need to do a Maven clean package, repackage the product catalog, and then rerun what I've just run here. Obviously that's not great for sort of very quick coding, sort of very quick iterating. There's a bunch of other techniques. The SAM local, the SAM CLI, GitHub goes into a lot more details. But what I wanted to show you today, and then the main sort of point in the video, is how to attach a debugger to the SAM local invoke. Now I'm using IntelliJ, I'm using the commercial version of IntelliJ. I'm more than happy to pay IntelliJ or JetBrains the money because I think it's a great bit of kit. But I believe what I'm going to show you now should actually work with the enterprise, or sorry, should actually work with the community edition of IntelliJ as well. The way we set up SAM local for debugging, and you probably saw just a moment ago when I accidentally showed it on the screen, it really is as simple as this. We run exactly what we ran before, but with a -d for debug argument. And we specify the port number. I'm just using 5858. So all we're doing here, generating event, piping it through to SAM local, and we're going to wait for a debugger to attach on port 5858. So we need to set up IntelliJ to listen in, to attach to that port 5858. We can do this, I'm sure many of you sort of do this kind of stuff all the time. It's edit config and you run here. I want to add a remote connection, so pop down. You may have different versions of things here depending on what you've got configured, but I want a remote, and all the default stuff is good, to be honest. All I want to change, just because I've changed it, is the port. So we go 5858. Simple as that. Click OK. Now you might want to give it a better name. I've just chosen it as unnamed at the moment. You can modify the name, but this is all we need really to get started. What I'll go ahead and do on my left window now is hit return. This will basically spin up Docker container, deploy the function in the background, and wait for a debugger to attach. So if I now go onto my IntelliJ, find the function, you can see I've already set a breakpoint here actually, but I can set another one as well. All I need to do now is run the config we've just set up in debug mode, simple as that, and that will attach to the actual container running. You can see you get a slight warning message there, maybe because I played around with various bits of config just a minute ago. But fundamentally now we have our generated event we've generated through SAM local. We are now piping this in as if it was an API gateway call into this function, and I've got all the access to my usual IntelliJ debugging features. I can step through all the code, I can modify data, and we'll see the results come through in the window here. I'll just actually pass this through, simple as that at the moment, and we can just see the data comes back. But that's a very simple video just to show you how easy it is if you're doing Amazon Lambda functions in Java, coding away, and you want to do some sort of hands-on debugging. Obviously I always recommend doing unit tests, integration tests to get the cycle time really tight. But if you do want to debug, you've got some gnarly kind of problem, you can totally do it using the technique I've just shown you, and you can also run SAM local, sort of an API gateway local, and do -d port number as well, and do exactly the same technique to debug a, say, browser invocation or a curled invocation of a Lambda, and actually step through, see what data the API gateway is generating, what it's sending through to you, and then you can debug all the various bits and pieces within IntelliJ. I hope this has been helpful. If it has, please do hit me up on Twitter at Daniel Bryant UK, and check out the upcoming O'Reilly book with myself and Abraham called Continuous Delivery with Java. Thanks a lot.